Hello everyone, welcome to uLearn Education Online channel. In the previous videos, we have seen how to draw the frequency spectrum of single tone AM signal as well as multi-tone AM signal. Furthermore, we have seen how to calculate the bandwidth of both single tone AM signal and multi-tone AM signal. So in today's video, we are going to see how to calculate the power of an AM signal. So we know that the definition or the mathematical expression of power is product of voltage and the current. So I can write the power as P is equal to voltage and current. So for an alternating cycle signals, we have to represent the power in terms of root mean square, nothing but RMS value. So I can write RMS VRMS into IRMS. Okay. So from the Ohm's law, we can write the statement that is the relation between voltage and current as V is equal to I into R, where R is the resistance and I is the current flowing through the wire. Okay, so if you use this relation, then I can represent the power in terms of resistance as P is equal to VRMS into, I can write IRMS value as, by using Ohm's law, VRMS by R. Okay, so finally the power value in terms of resistor as VRMS square by R. So if I consider the sinusoidal signal, then I can write the mathematical expression of V of t is Vm sin omega t. Okay, now for this mathematical expression, I want to calculate the power. But here the power value is in terms of root mean square value. So we know the relation between root mean square and the peak value as VRMS is equal to Vm by root 2. Now simply substitute this VRMS value in this expression. Then I can obtain the power as Vm by root 2 whole square by R. So I can write it as Vm square by 2R. So finally the power equation in terms of peak value, that is Vm, and this Vm is nothing but the amplitude of this sinusoidal equation, is P is equal to Vm square by 2R. So we have to remember this formula while calculating a power for an alternating cycle signal, that is an AC signals. So now we are going to see how to calculate the power for an AM signal. So in order to calculate the power of AM signal, first we have to find out what is the mathematical expression of AM signal. So as we know that from the basic definition, the S of t for an AM signal is C of t into 1 plus Ka M of t. So we have to remember this equation, where Ka is an amplitude sensitivity and its value is 1 by AC, and C of t and M of t, I am assuming it as a cosinusoidal signal. So I can write the mathematical expression C of t as AC cos 2 pi fct and M of t as AM cos 2 pi fm into t. Okay, now simply substitute these values in S of t expression. Therefore, I can write the S of t of an AM signal is C of t is AC cos 2 pi fct into 1 plus Ka is 1 by AC and M of t is AM cos 2 pi fm into t. Now do simplification, then we will get S of t expression as AC cos 2 pi fct plus AM by AC. So the ratio of AM by AC I can write in terms of modulation index. So I can write it as AC into M into cos 2 pi fct into cos 2 pi fm into t. Okay, now we use trigonometry relation. So here cos A cos B I can write as 1 by 2 into cos of A plus B plus cos of A minus B. So finally the expression of S of t for an AM signal is AC cos 2 pi FCT plus m into AC by 2 into cos of 2 pi of Fc plus Fm into T plus m into AC by 2 into cos of 2 pi of Fc minus Fm into T. Okay, so finally the S of T expression consists of carrier component AC cos 2 pi FCT and the upper sideband component which is the highest frequency, that is Fc plus Fm, and the lower sideband component which is the lowest frequency, that is Fc minus Fm. So finally I can write the total power in AM signal. I can represent it as PT is due to the carrier power which is indicated with PC, and the upper sideband power which is indicated with P and P USB, and the lower sideband power which is indicated with P suffix LSB. Okay, so here the upper sideband power and the lower sideband power I can write it as a sideband power. Okay, so P sideband power is P USB plus P LSB. Now let us consider this total power expression as 1 and this sideband power expression as 2. So I can write the total power in terms of sidebands as total power PT of AM signal is power due to carrier signal plus power due to sideband signal. And here that they are consisting of two sidebands. One is the upper sideband and second one is the lower sideband. Okay, now we have to calculate what is the carrier power and what is the sideband power. Since we have obtained the relation between the power and the peak signal amplitude is P is equal to Vm square by 2R for the relation V of T as Vm sin omega T. Okay, now here we are having a carrier expression or carrier term. Now what is the carrier term? So it is nothing but AC cos 2 pi FCT. So for this we have to find out the carrier power. So I can write the carrier power PC is equal to, here Vm is nothing but the peak amplitude of this Vm sin omega T. So here the peak amplitude for this AC cos 2 pi FCT is AC. So I can write it as AC square by 2R. Okay, so this is the carrier power. Now we have to find out what is the sideband power. So here the sideband expressions are m into AC by 2 cos 2 pi Fc plus Fmt and m into AC by 2 cos 2 pi of Fc minus Fm into T. So here calculate the sideband power. Okay, so the sideband expression is m into AC by 2 cos of 2 pi of Fc plus Fm into T plus m into AC by 2 cos of 2 pi of Fc minus Fm into T. So this is the upper sideband power component and this is the lower sideband. So if I write or if I find out the upper sideband power, then for this upper sideband expression, what is the amplitude equation? It is, so P USB is equal to, amplitude is m into AC by 2 whole square by 2R. From this relation I have written. Okay, so it is equal to m square AC square by 2 square is 4, so 4 2 is 8R. So this is the upper sideband value. Okay, and similarly I can write the lower sideband as P LSB is equal to m into AC by 2 whole square by 2R. So which is equal to m square AC square by 8R. So the lower sideband and upper sideband power values we have find out. Now finally the sideband power I can write as P sideband is equal to P USB plus P LSB. So upper sideband is m square into AC square by 8R, and lower sideband is m square into AC square by 8R. So finally we will get it is 2m square AC square by 8R. So 2 ones 2 fours. So it is equal to m square AC square by 4R. So finally the carrier power PC is equal to AC square by 2R, and the sideband power PSB is equal to m square into AC square by 4R. So I can write the total sideband power PT as PC plus P sideband, which is equal to AC square by 2R plus m square into AC square by 4R. Now take common AC square by 2R. So if I take common AC square by 2R, then it is 1 plus m square by 2. Okay, so it is AC square by 2R plus m square AC square by 4R. So this is the power of AM signal expression. So finally it is PT is equal to AC square by 2R into 1 plus m square by 2. So I can write this AC square by 2R as a carrier power. So final expression PT is equal to PC into 1 plus m square by 2. Okay. So for an assumption of message signal and carrier signal mathematical expressions, we can find the total power of AM signal is the power due to carrier signal and the power due to a sideband signal. After doing simplification, we are getting the carrier power as AC square by 2R and the sideband power as m square AC square by 4R. Okay, now simply substitute this carrier power and sideband power in the total power equation. Then finally we can get the total power as PC into 1 plus m square by 2. So this is the procedure how to calculate the mathematical analysis of power for an AM signal. Thank you for watching our videos. Please subscribe to our channel and keep supporting.